So as a recap of last week, if you remember, we created some classes, actually a single class called person. We put it into a module, and we also had something called a database, and we were saving it to our file system, the people that we create, right? This is the code from last week, and yeah, now I'm gonna build a little bit on this because there is actually something missing that requires further explanation also for your homeworks. If you remember, a class is a combination of behavior and data and state. So a person can have some state, some properties like their name or their age, right? And then a person have behaviors. If you remember the first week, we used something like make friends with so that people could make friends with other people. That's a behavior, right? That's an action that people are doing. What do we use to make actions in classes? There's something like, what is make friends with? A method, a function, right? Functions are actions. So let's add something called, say, name to the person. This is the stuff that we did on week 2. And if you have the code from week 2, you can follow up. If not, don't worry. You can just watch and it'll be all right. Okay, so say name is a behavior, right? It will tell its name. Currently, we can do it with console log this name, and it will just log the name of the person to our console, basically. So the person class is on the left. Our code is on the right, and I'm going to go and run it. It was just logging my age, and now let's say here arman.sayName. Okay? Hello, Ilker.
Hello.
So when you run it, you'll see that it prints the person's name. There is no magic, right? This is what we did last week. And for the newcomers, we basically covered the basics of object-oriented programming with classes and functions. So it's very, very simple stuff. But if you think that you are lacking behind in this class or like with the scope of this lecture, don't worry, we have the screen recordings of the past 2 weeks. So you can find them online and you can watch them and get the same material that everybody got. And we had some homeworks as well. You'll hear them when you watch the videos. And of course, we expect you to do them. But yeah, just try to follow along. And if you have any questions, don't even think that it's dumb or it's inappropriate. Every question is valid. And we have a couple of people around that will answer your questions. Just raise your hands. Someone will come and help you out. So don't worry about it, okay? So arman.sayName is a behavior and logs the name to the console. That's fine. Let's try moving this behavior after loading the database from the file system. If you look at the code, I'm creating 2 new people. I'm calling them instructors and putting them in an array. And then I'm saving that instructors array to the file system. And then I'm loading it from the file system. And obviously, the application which loads the database would be another application, but this is just a demo. So I expect the same behavior after loading the database from files, right? Obviously, it should work. I saved the instructors to the database. I load them from the database, which is a JSON file on its own. Here, I have 2 instructors, and I expect the behavior to work. So, again, you can log the age or the name of the instructor. It's there. Let's see if the behavior is there. So loaded file 0 gives me what? Raise your hand and tell me what loaded file 0 is. Come on, just say something. Anything is valid. You can even say, yeah, please. Sorry? The first object in the file. Yes, that's actually correct. Loaded file is the object version of the database. So this is our database. This is called JSON, JavaScript object notation. And it was text and we converted it to objects. So it's basically giving me the instructors. I can call this loaded instructors. So the first one is Arman, like my object. All right, so previously we could do arman.sayName, right? Here. And what should happen is when I load it from the database, I expect the first object still have the same behavior. So this should work, right? Oh, sorry. sayName. Nope. So when I run it, I get loaded instructors sayName is not a function. Why do you think that happens? Please? Yes. Beforehand, like the Arman object here is called an instance of the person class. So we created a new person, and this is vocabulary. We created a new person called Arman, aged 33, and we put it into a variable, and that person had that behavior, had that action, sayName, because it's a class that we define on the left, you see. We saved the objects to the file, and when we were converting it, if you remember what we did in the database, we said we stringify the database, the people. We turn them into strings, okay? And it turns out that functions or behavior don't really convert into strings. So when you convert an object into a string, you get the most basic properties, which are, you know, name and age for those people. The properties, you get the data, the state, but you don't get the behavior. So, and actually, if you look at the file on the right, there's nothing that says these are people. They're just objects. So we're kind of saving a snapshot, a picture of an object. Now, what is a picture? What's a photograph? It's a depiction of a scene, a 3D scene, to paper, right, which is 2D. So for example, you don't have depth information. When you take a picture, it's just a frame of a very limited frame, and you don't have any other information about that moment, that instance. You don't know when it happened. You don't know the third dimension or any other property about that view. It's just a snapshot of the current frame wherever your camera is pointing at. So this is like that. When we're saving it to the database, we're just saving the properties, but not the behavior, not the actions. So But this is bad, right? I saved something to the file system, I read it back, and I want those actions back. How do I do that? Raise your hands and tell me something. Like, what can it be that puts those actions back into these objects so that whatever I read can still say its name? Raise your hands. Yeah, please.
Make it a constant.
Make it a constant? Could work, but doesn't give you the behavior because still, you don't know that these are people. There's this file, and it doesn't know, like each object there, doesn't know if they are a person or an animal or whatever. So, yeah, please.
We can create a new object.
We can create a new object. Yes, that's actually right. We need to cast and that's the terminology, we need to cast the JSON object, like this object here, to the person class. We need to tell in our program that, hey, this is a person. I read this from the database, and then I create a new person with these details. There's something that you need to see here. We are recording name and age, right? It's exactly what goes into the constructor function here. They are the exact parameters that you use to create those people in the first place. Here. The name and the age. So what you can do actually, after reading this file, you can create new people out of these. Make sense? Okay, so what we do is first person equals new person. Loaded instructors is the thing that I loaded back. 0 dot, what am I going to write here? Raise your hand and tell me what I'm going to write here after this dot. Think about it. And don't worry, you can say anything. Yeah, please. Name, of course. Why do I write name there? Yeah, raise your hands. Please. Yes, because it's the first parameter of the person object. As you see here, this is a constructor, and it receives a name as the first parameter. So I'll give the first instructor's name. What should I write here? Age. I need something before that. What? What? Not? This? No, because there is no this here. But I'm going to get the age of the first instructor, right? Loaded instructor 0.age. Okay. Now I can say first person dot, it already autocompletes, say name. I save it, I run it, and I get the name. It worked. Yay. Does it make sense? Raise your hands if it doesn't make sense to you. Does it make sense here? It's okay, no problem. Don't worry, just raise your hands if it doesn't make sense. It's kind of like black magic, so it's all right. All right. So let's address your concerns. What didn't make sense for you?
Well, I was just kind of lost.
Okay.
What theme are we using?
What theme I'm using for the colors?
Because I have it backwards
I'm using something called Groovebox. Preferences, color theme, yeah, Groovebox dark. But anyway, so you were saying? The previous person, the previous Arman is here, but think that these are two different programs. The first one is just creating those people and writing it to the database. The second one is loading from the database. So you don't have the first one. And you need the behavior of say name of that object. How do you get that? You create new people. All right? Another question. Just don't be shy. Shoot your questions and I can answer all of them. There was a hand back there. Yeah, you solved it? Perfect. Okay. So this is nice, but it's not so scalable if I have a lot of classes lying around. Like I have to remember how to create them all the time, like what are the first parameter and the second parameter and stuff, right? This is not ideal. What would be a better case is if person class knew how to convert objects passed into it into new people, into new person instances. So that, you know, I don't write this, but I write something like person.create, for example, and say loaded instructors 1. So, what is the difference between the first one and the second one, line 17 and line 19? Raise your hands and tell me. Please?
You're not creating a new instance.
I'm not creating a new instance of person? Yes. And who is doing it? Because this thing will work as well. When I type second person say name, it will work. There is no create function yet, don't worry about that. But basically, I don't want to write this code, but I want to write this code. Tell me the reason, a similar reason for, or an estimated reason for why I don't want to write the first one, but I rather want to write the second one. Raise your hands. Yeah?
The first one, you call the constructors, but the second one, you simply just create. I think it's...
yeah, but why? Why? Why do I do that? Why do I need that? Please? To do it dynamically? Yeah, but what does it mean? What differences do you see between the two lines? Just look at the code. Yeah? Yes. Yeah, that's exactly it. So to write the first one, you have to know that you have to get the name and the age to create a new person. This looks trivial when you have only one class and you have two properties and you have the class open on the side, right? But it gets really confusing when you have 200 classes and it's really hard to even find those classes. So it would be better if you didn't care about that, you know. If you look at the second line, you don't need to know anything about the inner properties of those objects. You just say, hey person, that's a class. Hey person, create something for me and here is what I got from the database. Here's what I read from the database. I don't know, I'm totally agnostic, please.
Where is this create function from?
Exactly, that's what we'll do now. That's what we'll create now. But yeah, ideally the second one should work. And listen very carefully. The next sentence, maybe it will be useful in a couple of years. in your programming career, but this is how you should design software. You first write something that's inexistent, that's not there, but you first write your dream, like what you want it to look like. And you first test it, see if it looks good, and see if it satisfies you. And if it does, then you go back and start writing the actual implementation. So what I did was I just said, you know, there should be something called create on the person class that will do the creation for me so that I don't have to remember those variables. So I first came up with the problem, then I designed something, I wrote it down, and it looked good. And then I decided, okay, this is good, it satisfies me, and now I'm going into the actual implementation. And how I do that is I add a static function called create, and raise your hand if you know what static functions are. 1, perfect. 2. Oh, or is it a question? Or oh, perfect. Okay, raise your hands if you have programmed Ruby before. Okay. You should have a create function there, no? Do you remember create in Ruby? No? Oh, maybe it changed. I don't know. I was using Ruby like 12 years ago. Probably something changed. What? Yeah. But anyway, a static function is simply a function defined on the class itself and not the instances. So it's not behavior. That's why I'm calling it a function. Otherwise, I would call it a method. Because if you remember, behavior, actions are methods, but then we also had, you know, free-floating functions from the first lecture. You may remember that. But sayName is a method, an action of an instance, of a person, of like Arman or Miri here, or the first person or the second person. But create actually is a function that belongs to the person class. So it is something the person class can do. That's what a static function is. It's always there, but sayName is only there if you have a person, if you have created an instance. All right, so what this should do is it will return a new person, and it should take a parameter called object, for example. And like when I open the parentheses, my Visual Studio Code already gives me the heads up. It says, oh, you want to write person, you want to create a new person, then you need the name and the age, and you will get a person in return. So I'm going to do object dot what? Name. Here. Raise your hands and tell me what I need to type here. Yeah. Yes, exactly. Object.age. And yeah. All right. Let's see if this works. Oh, it did. Amazing. I ran the code and it worked. Let's remove the first person and only leave it the second person. It still worked. So, yay, dancing time. It's motion activated. But yeah, so this is what we do. Person.create gives you a new instance. So this was what was missing from last week's class and from your homeworks as well. Most of you saved to a file to the database and read from the database, but you never tried to execute the actions on the objects that you read from the database. I purposefully omitted it so that we could cover it today. But this will be the part of next week's homework. So I want you to visit your homework for the second week and actually add this create methods for every class, read them from the database, and create them like this, and then see the interactions, the methods are still working. Is it clear? We can always communicate over Slack if you have any questions as well, so don't worry about that. So how do I do the first person the same way? I just write first person equals person create. What do I write here? Raise your hands and tell me. I'm on line 19 and I want to write something inside person.create, please. Loaded instructors 0. That's right. Okay. Is this good? Can we improve this? Tell me. Yeah. Sorry? A loop. Yeah, we can do a loop to improve this. That's right. How did we do loops? If you remember the first week, we were using something called for each. So we were saying loaded instructors for each instructor. Person create instructor. Something like this. So this is a loop which currently does nothing, unfortunately, because it's just creating new instances, but it's not saving it anywhere. Now, there's a special version of for each that I'm not going to go into a lot of detail, but I will share it over Slack for you to read. But here's an example. Look at this array, 1, 2, 3. Okay? I want to multiply every number by 2 in code. I use something called map. Raise your hands if you know what a map is. All right, a few people. Great. So a map takes an array and gives you another array by running each element through a function. So yeah, I'm just multiplying it by 2. This is a function here that takes in a number and returns the value of the number multiplied by 2. Yeah? And you see, when you run it, you get a new array that has the numbers multiplied by 2. So this is a function on every array, the map, and or method. It's called array method, and I will send you a link to read more on array methods. They are really important, and some of them used already some of the array methods in your homeworks, and we will make use of array methods in the coming lectures. But again, map takes an array, takes each element in the array, and transforms them, maps them to something else, to another value. So I take a number and multiply it by 2. So what happens if I take an object and I convert it into a person? That would be awesome. So let's do that. So loaded instructors.map. And actually I can simplify this by just writing person create. Now this is really tricky. It's like black magic. You just have an array, loaded instructors. You map it to another array by running each object through the person create method. And let's assign it to a new array. Let's say converted instructors equals loaded instructors. And I can actually do this. Can you still read it? Is the font size okay? Okay, the ones on the back, can you read that? All right, good. And let's say converted instructors 0.sayName. Let's see if this will work. Yes, it did. Here?
Yeah.
No. Well, it takes a parameter.
Okay.
And it takes the object. But if you remember my numbers example, the function that you pass into the map, it was something like this. Like this here. So this is the function, right? It takes a parameter and converts it to another number. This is what person already does. It takes a parameter, converts it to something else. What map does is it automatically passes in each number to the function that you provide here. So here, what map does is it first takes 1, puts it as n, and runs this function. Then it takes 2, puts it as n, and runs this function. Then it takes 3, and does the same thing. And in the end, you get another array. And that's what it does here as well. When you do loaded instructors.map, it takes the first instructor automatically, runs it through the person create function, like here, gets the response, new person, object name, object age, does this 2 times because I have 2 objects, and then saves the result in something called converted instructors. Converted is not a nice name, but just bear with it. Yeah. Perfect question. Yes. What if the function has 2 parameters? This is tricky. Let's demonstrate that. Let's put a second parameter here, param2, and then let's even put a third one, param3. Okay? Let's also log it. Console log param2, param3. And the message to identify it. What do you think will happen when I run this? Raise your hands and tell me, what will param2 be? Anyone? Just guess. Undefined. Yeah, that's a very good guess because I'm not actually giving it any other parameters. Let's try node index.js. Okay. Oh, very interesting. It didn't get undefined. Param2 is actually a number, 0 or 1, depending on the object. And param3 looks like the same thing. So what do you think the number is, param2? The index, yes. It is the order of the objects. Like the first object, if you remember, it's 0-based, so it starts counting from 0. So the first object is actually the 0th index, and the second object is actually the first index. So the number is actually where you are in that array when the function is invoked, when the function is called. Does it make sense? Raise your hands if it does make sense. Sorry? Why is it the index? That's basically the definition of the map function. Because sometimes they say, you know, it's fine if you get the elements of an array, but what if you also want to know where they are in the array? For example, let's say you want to add a progress bar, okay? A progress bar is something that shows you the progress of an action from 0 to 100 as a percentage. And how do you calculate that? So how do you know when you're processing these people, the instructors array, how do you know after each operation where you are in that progress bar? If you don't have an index, it's kind of tricky. That's why an index is very useful in a map function. So they thought, okay, people will use this a lot of the time, so let's just give it as a second parameter. So normally you don't use it. Normally you don't even need it. And in our example, we didn't even put that, right? But it makes sense, for example, if you want to do a progress indicator. And our progress would be 0, 50%, and 100%, right? Because we have 2 people. If we had 3 people, we could dynamically count it. It would be 0, 33%, 66%, and 100%, right? That's why the second parameter is an index. What do you think the third parameter is? The whole array. Yes. Because again, they thought when designing the map function, well, it may be the case that the function that is passed to the map doesn't know anything about the array, right? It just knows the objects one by one. But what if there's useful information in that array as well? But if there's another thing, what if I want to check the next item? What if I want to check the previous item, right? There should be a way to do that. And they said, okay, it doesn't hurt to add more parameters to functions. Let's add as a third parameter, and we will just pass in the whole array. We will just pass in whatever is running on the map function. And they said, okay, then we will do the array. That's why you see the whole object here, the whole 3 people. And if you don't need them, you don't have to use them. Do you think, raise your hands if you think there's another parameter. Everybody thinks this is enough? Like 3 of them? Why? It could be 4 or 5, because we already started once, right? What prevents us from having more parameters? Actually nothing. We could have more parameters, but that they decided that it's enough, and we don't have any more pressing needs, so there are no further parameters down the line. But that was a very good question, thank you. So I delete this, and you run the code, you get the name. All right, raise your hands if you're lost, if you feel lost. And it's perfectly fine to feel lost. There, there, there as well. Okay, so I call for the instructors. Just move around, and there's a lost person there, here, and there as well. So let's bring them on board. And if you think you're lost because you didn't attend the first 2 classes, that's fine. Again, you will have the video recordings. And yeah, raise your hands if you need me to repeat any of the material so far within this lecture. Nobody? Okay. Yeah. Oh, yeah, I see. That's again a very, very good question. It's an advanced technique in functional programming, and we can discuss this later on Slack, but there are obviously a lot of ways to put pre-bound parameters within functions. Basically, you make another function that returns a function, and you bind that parameter there. But yeah, we can discuss it on Slack with examples. But it's a huge topic. There was another question from that side. Is everything clear? Is it too fast or is it too slow? Raise your hands if you think this is too slow. And it's perfectly fine. Oh, good. Yay, great. All right, this is basically everything that I want to tell you about reading stuff from a database, from a file, and putting behavior on them. All right, and again, this will be your homework for the 3rd week. I want you to do your databases this way. Read from the database, convert them into objects, and make sure that the behavior still works. And you have the functions, you have the output of the functions, and they still work. And then I will move on with this week's topic, which is asynchronous programming. And yeah, it is the first advanced topic that we will cover in this class. So if it feels too advanced, feel free to stop me and ask, please. So it's about the order of execution, and we saw it in debugging. Each line we put a breakpoint, and we saw that we executed each line one after the other, right? That's synchronous. That worked because each line here is doing something, takes their time to finish that job, and then we continue with the next line. But here's the question, and you all use websites, so you are all familiar with this. When you click something on a website, some action happens, right? For example, you fill a form, like the comment box in Facebook. You write something, and you click comment or send. I don't know what the name of the button is. And it does a job, right? It sends that value back to the server. Some things happen, and then your text, your comment appears, and hopefully you're not harassing people with that. But yeah, how does the browser know that you clicked something? It was standing still. It drew the page, it rendered the page, your comments, your Facebook feed, and then you type something and you click the button, and then it said, oh, something happened. And it saved it to the database, right? How does it work? How do you think it works?
Is it listening?
Yes, it's listening. It's aware. Like the browsers, the web pages are aware of your interactions. They're listening for your interactions. They know if you type something, or they know if you click on something. And they can do actions based on these listening events. So they are listening for the events that you generate. What are typical events? Raise your hands if you know some of the events that we use in the browser. I just mentioned some of them. Please.
Click, hover.
Yeah, like clicking something, or hovering the mouse over something, or scrolling. Or again, key press is another event that you generate. Every time you do something on a web page other than looking at it, even closing a web page is an event. It triggers an event, and the browser is listening to it and is doing something in return. Now, it's not the topic of this course, what happens in the browser, but it's important to understand that, you know, every action you do actually creates an event, and the browser can respond to that. Now, that's tied closely to asynchronous programming. Why? Raise your hands and make a guess, please.
Because it can happen anytime.
Yes, because it can happen anytime. The browser doesn't know when you will click. Like, it doesn't say, okay, here's Arman, I created a new person, and now Arman should click something. Arman, click Mihri.profile. So Arman goes into Mihri's profile. There's no scripted human behavior, right? You can click on a person's profile whenever you want. So there's no line that I can execute. So there must be a way for the browser to indicate its interest in those events, and then it will just wait. It will just say, okay, I told the environment that I'm interested in clicks, in profile clicks. Whenever such a thing occurs, just let me know, because I will execute some code. that is an asynchronous action. So you have some synchronous code here, line by line, and in one of those lines, it's actually something like window.addEventListener, click, something like this. And then you give it a function that takes an event, obviously, and you do something. Okay? And in fact, why don't we just try this in Chrome? All right, I run this code. We know that event listener click. It was synchronous when I wrote it. There are 4 lines and each line executed. You can see actually that let's run this. When I run it, you can see that line 3 executes and then line 5 executes and not line 4. Why? Raise your hands and tell me if you know or if you have a guess for why this might be the case. Yes? Yes, it's waiting for the click. Because line 4 is actually what happens when I click the page, right? I said, hey, I want to add an event listener for the click action, for the click event, and when it happens, just let me know. So I run this, and I get the hello message, and when I go click the web page, I get the alert hello. Now, this breakpoint thing doesn't work the way I expected it.
If you're making an app, will it use this kind of Windows stuff as well?
So the question is, if you're making an app, does it use this kind of stuff? Yes. Not exactly the same syntax, but it's always something .addEventListener. Or, you know, there are some frameworks that make these easier for you.
So this is just for the browser? Is it?
Yeah, it's for the browser. And like, it's one of the syntaxes that you can use for the browser. There are tons of other solutions. But yeah, so hello, alert hello, occurs asynchronously. Now, is it a little bit clear what asynchronous is versus synchronous? Raise your hands if it's still unclear. Okay, a little bit unclear. That's fine. That's all okay. So again, the browser doesn't know when I will click the web page. Let me run it. I can click it as much as I want, right? Nobody's telling me how many times I can click the browser. So it cannot execute this alerting the hello box synchronously because it doesn't know how many times I will do it. So there has to be some mechanism to indicate to the browser that I'm clicking it and here's your chance to do something. You can listen to these events and then you can basically run any code that you want. So it's like the browser, or this code tells the browser that, hey, whenever there's a click, let me know. Or in other terms, it's like you calling a friend and the friend is not home, they're not picking up the phone, and you leave them a message and say, hey, I want to tell you something, call me maybe, and raise your hands if you can't speak to the machines, the recording machines. Yay, yeah, I'm not alone, that's perfect. I hate those, I never speak into them, I never leave a message. Yeah, but it's something like that. You call somebody and say, hey, you know, I know you have some business, do it, but whenever you're free, just call me back. Because I want to do something, like I have something to tell you. I want to show this alert box, okay? And it's basically the same mechanism. And when I click the window, it says, oh, okay, now here's the chance that I'm looking for, and I'm calling you back. And to say, hey, now is your chance, do whatever you want. And the code says, okay, hello. Now, this terminology is also in programming. We call these functions here what? Raise your hand and give me a name. Yes? Sorry? Greeting? Could be. That's a good name, actually. That's a better name. But there? Callback functions. Yeah. Because naming is hard, so people tend to be unimaginative about naming. As I told you, we are telling, hey, whenever there's a click event, just call me back. And the functions are called callback functions. It's really unimaginative for the action. But yeah, this is the terminology. So there's an event coming in, or there's an action that is executed, and then there's a callback function that gives you the result of that event. All right, so let's go back to our code and let's see how this actually applies to us. I can actually make it full screen and use it like this. All right. So let's go to the database. If you remember from last week, I told you that I will talk about the meaning of these sync names in our functions next week, and we're already there. So we're kind of in the future. And now I hope it makes some sense for you what the sync here means. Raise your hand and tell me what sync means here. It's very simple. Yeah. Exactly. That's perfect. Yes. It basically means read the file synchronously. You all saw that, right? Sync stands for synchronous, and I was actually asking for that. So it means read the file synchronously or write file synchronously. So what happens when you try to load a file is when you put a breakpoint here and when you try to load it, let's see if it will work for us. And obviously it didn't. Let's see if I can put a breakpoint here. No, I can't. I wonder why. Oh no, I'm not on week 3. I'm in week 2. So here, sorry. Okay. So I run the code. I have a breakpoint at line 4. I go through it. I create an object called Arman. You can see it here. I have an object called Arman. I don't have an object called Miri yet. She is undefined. Miri, you are undefined. But let me redefine you. And now Miri is actually defined, and she is here. So I create something called instructors.
Can I say something? Actually, my age is 31.
Nah.
Maybe it's because it's undefined.
Yeah. So I want to save the database and see the execution will jump. It's currently on line 12 here. It will jump to line 4 on the database file because we were processing it synchronously. And I run it. Obviously, I execute line 5. I go back to line 14 here. I want to load the database. And let's add another breakpoint there. I try to run it. I end up at line 6 on the database. And I'm doing the synchronous operation again, reading it, and I end up at line 18. So this is what synchronous is. You have a code here. Whatever it's doing, saving, loading, anything, they happen synchronously, line by line, without interruption. That's the most important part. You cannot interrupt this code. You cannot say, okay, now I want to execute something else. I want to get the age of that person, the person that I created before. You cannot do that. This basically takes your command, like, hey, read the file, and then executes it. And doesn't even care about the time it takes to execute that thing. And this is the biggest problem of synchronous programming. If you have previous programming experience on any other language, in PHP, in Ruby, in Python, or basically most languages like C, Java, C++, C#, they are all synchronous languages. And they unfortunately don't really have that many asynchronous properties or operations, or they are not built into the language. But since JavaScript is a language built for the browser, asynchrony is built into the language. And as I demonstrated on the browser, you can click and you can generate events. That's the way you do JavaScript. That's how JavaScript works. And so it's an easy language to use for asynchronous operations, and it's why it's redefined backend programming. And that is the question, why? I just mentioned databases. We are reading a record from the file system, right? We just have 2 records and the file is located on my computer, so that's fine. What if the file is located in another computer on the other end of the world, in another continent? What if the file actually has 2 billion records? Like, let's say you're getting the list of users in Facebook, and Facebook has like over 1.5 billion users or something like that. How long would it take to read that file from a database like we did here? It would take forever. Basically, it's impossible because that file is huge. So even if we could save the function, save the database, we wouldn't be able to load it because it would take forever. So, and my execution would not continue if it were synchronous. But unfortunately, this is how other languages work mostly. When you're doing a query to a database, everything happens synchronously. You create the query and you send it to the server, to the database server, and you cannot do anything else until you receive a response. That's why most of the web applications are really, really slow. Like when you want to save a new record, it just waits. It's not even doing anything, but it just waits for the database to finish, to end that query, to continue work, because it's synchronous. And it's what we do here. But with JavaScript, it's actually very, very easy to unlock a new mode of operation. Because think about it. When you're reading a file, what happens when you want to read a file? What happens when I want to read this data.json from the file system? I tell the operating system, hey, there's a file called data.json, and I want to read it into memory, give me the contents. What it does is it goes to the hard drive, the hard disk. If it's spinning, if it's a mechanical hard disk, from the old times it's even worse, because it has to apply some electricity, spin some disks to find where the data is located, and read them bit by bit and give you back the data. It takes a lot of time. And my code just has to wait. I'm not doing anything. I'm just waiting for the operating system, for the hard disk to spin, to give me that file. And again, if this is like a billion records, a million records, it will just take forever to get all that disk from the hard disk. So and I'm just wasting resources. I cannot serve another customer while I'm doing that because I'm in a synchronous language. So they thought, well, this doesn't work and it's not good. It's just wasting resources. So can there be another model? And actually there can. Just like the browser event of a click or a callback. Do you have a question?
Yeah, I have a question. Like, if this is the case, I have to use Python or Ruby. Like, if this is the case, like, I could not be able to use easier than those languages.
That's the point. Yes. Yeah. So there's a lot of discussion behind this, but this is why we're learning Node.js, because it enables asynchronous programming very, very easily. And in other languages, obviously nobody is doing synchronous programming these days. Yeah, exactly. There is something called concurrency, and Python has like G events or events, or like a lot of other libraries that enables asynchronous programming. And it's now, they're kind of trying to build this model into every major language because the old model just sucks, as I told you. And what they have to do when they want to serve multiple customers, when they want to read the file 10 more times, they just create a new program. They just run it again, run the same program again. Because the old one is just waiting for the record. So that model doesn't really scale. It's really, really hard. And you're just wasting resources. You're doing nothing. Your CPU is just waiting for the hard disk to spin to get you that file, the content of that file. And that's why JavaScript is actually very suitable for backend programming. Because in backend, you mostly you call other web pages, you call other web servers, or you call databases. You say, here's my command in Facebook. Save it to the database and make it available to the world. Like send out notifications to everybody. And what happens if you have like 10,000 friends, or like 5,000 is the max, right? What happens if you have 5,000 friends? They all get notifications, right? But what happens if all happens synchronously? That wouldn't work. And that's why we need asynchronous programming. And again, that's really easy in JavaScript. What we do is, in this model, we say, okay, Mr. Hard Disk, I want to read this file. Do it separately. Don't bother me. And I'm not going to wait for you. I'm going to do other stuff. I'll tend to my own business and I'll do other stuff. But whenever you're done, just call me back. Yes, whenever you're done, just call me back. Make sense? Now, do you see how it maps to databases, what we did in the browser? In the browser, we said, the code that we ran said, hey, I want to listen to clicks. And whenever there's a click, just call me back because I will display it in an alert box. That's what we do for databases and files and everything else as well in backend programming. We say, hey, read this file from the file system, or translate this text for me. Google Translate, please give me the translation for this text. And while you're busy working on it, I will do other stuff. And when you're done, just call me back so that I can operate. Now, if you're familiar with multiple threads or multi-threaded programming, maybe you heard about that. This is not multi-threaded programming. JavaScript is still single-threaded. And everything that happens in JavaScript is still single-threaded, which were akin to synchronous programming before, but some smart engineer discovered that single-threaded doesn't mean synchronous. I know I'm sounding like from outer space, but I'm just trying to give you some technical words and jargon for this thing, and so that you can hopefully look them up on Google. So we're not doing multi-threaded programming. For 30 years, people thought multi-threaded programming was the answer, but it came with its own problems. And then they discovered that, no, actually, we can still be single-threaded, and still, we don't have to wait for the hard disk to finish its job to do other stuff. And that's what Node.js is about. And when it came out in 2010, that's why it was too fast. And it basically blew people's minds away because this way of backend programming didn't really exist back then. So there was a question on the side. Oh, yeah, do you still have that question?
Yeah. So if we do something like this, that you make a asynchronous call to read some data, and then that's going on in the background.
Yeah.
But what if I need to do something with the data?
Then you do it after you get the data. You do it in the callback function.
It's the same as synchronous.
For you, yes, but for others who are trying to do the same, it means it's really different now that they can execute. For example, while you're waiting for that data to return, you can compute a lot of other stuff. You can compute the number pi, for example, while you're waiting for the database or anything else. You can serve another customer. And when you get the results, you'll get a callback function and you'll continue execution. And yeah, perfect, in time. So we give a break for like 15 minutes and we meet at 8:30 to talk about how we do this in JavaScript. And again, there's food in the kitchen. Please use that kitchen on the back. And you're welcome to have anything you like. Thank you. There's a graduation event at the end, and we will ask you to do a project until the graduation. Actually, maybe you should start thinking about it, because since this is a backend and Node.js class, you're expected to do a backend application with the stuff that you learn here. Okay? And there will be a graduation event and some certificates that we designed for you as a token so that you'll remember us in the future. And after that, basically we will give out some free tickets to a conference called .js, which is one of the coolest conferences, JavaScript conferences around in Europe. And we have 2 tickets for that to give out. So we'll, I don't know how we will do it, but maybe we'll pick the most interesting project after the graduation event. And we are also still trying to get more tickets to other conferences for you to attend, basically. But there's another opportunity. Since, I don't know if you already know it, but I'm working at a company called Unu GmbH, and I have a lot of friends who are helping us today. I want to offer a 3 or 6 months internship to a graduate from this course. So if you work hard and do all the homeworks and you can successfully graduate and present a project, I actually want to offer at least one position of internship for 3 or 6 months. So, and hopefully convert it to a full-time position at the end. And I will try to pull in more companies into giving a hand with this program to increase the number of people to get internships. So there are several reasons for why you should continue working on the program. And I don't know, I hope you'll be interested in these offerings that we have. Okay, welcome back. Hey. So, a recap of the last session, we talked about asynchronous programming. Oh, sorry, before we began, my friends told me that some of you are struggling with the editor, the IDE, Visual Studio Code, which is totally normal. Like, I'm using these tools for over 20 years now, but you're just starting out. So it may not be as quick as I am with the editor, doing stuff around the editor. That's fine, don't freak out, but you can spend some time on your own to figure out what the IDE does. I mean, go through the menus, see what each menu item is doing. There are a lot of shortcuts that you can use to improve your productivity in the code. For example, line comments. This is the one that I'm using most. It's command/, so whenever you do it, it comments out the line automatically. So there are a lot of shortcuts that you can use, and you're encouraged to check them out and use them. the most useful ones for you. And a second recommendation from my friends was the NodeMon. So if you remember, we were using a tool called NodeMon to refresh the file every time we change something. And when I ran it, the last time it went into infinite loop because we were creating a new file, a database file, every time you ran this code, which was a change in the file system. So it reloaded the script, which created another database, so on and so forth. And some of the attendees actually came up with the idea of the ignore parameter in Slack. So we could do something like this. Yeah, nodemon -- ignore data.json, so that it doesn't care about the changes in that file, because that is the file that we're creating all the time, and looks for changes in other files. And whenever I'm basically whenever I'm changing anything in the file and saving it, it reruns the file so that I don't have to go back to the terminal and do node index every time. And I wanted to take this as an opportunity to show you how events occur in the backend. We saw in the front end that we wrote like window.event, add event listener click, and said whenever there's a click, call me back and I will execute a function called hello. And this is an example in the backend. NodeMon is an application, a process on its own, and you see it's waiting for changes before restart. It's waiting for the change event, okay? Change event in the file system. So whenever I'm changing any file, so here I'm taking the second person and calling the sayname method. Let's take the first person, and I'm just hitting Command S to save the file. It just reloads, and now you see it prints my name again, the name of the first person. How does this work? It works exactly the same way it worked in the browser. There's an event, a file changed event or a file save event that this program NodeMon is listening, and whenever it sees that there is a change event, just restarts my file. It goes and says node index automatically. Again, it's an example of events and asynchronous programming and event-driven programming. It's called event-driven programming because you are reacting to events. If there are no events, you don't do anything, which means events are driving your application. And yeah, hence the name. Okay, let me continue with this. And I have a question. How do you think we can convert these synchronous functions to asynchronous functions? Like, instead of writing to the database file synchronously, I want it to be asynchronous. How do you think we do that? Just raise your hand and make a guess.
It's an event.
It's an event. Another guess? Don't be shy. You can say anything.
Try 8 before shape.
That's a very good idea. Yes, it could work. I'm looking for another. Yeah? Have a callback function? Yes, exactly. If you're doing something asynchronous, you have to have a callback function. That's right. But how do I make this operate asynchronously? Now, this is synchronous, right? Yeah. Yes, of course. Come on, this is like write file sync. It's as if an extension to the original version, which is fs, and fs stands for file system, fs.writeFile or fs.readFile. These are the original versions, and these are the versions that you should be using in Node.js. because I told you already that JavaScript is best for asynchronous programming. So the default is obviously asynchronous. And the synchronous versions are the extensions, are the additions. That's why to make them synchronous, we have another function called readFileSync. And if you remove it, it will be asynchronous. Now, let's see how this works. Let's execute this and see how it works. Okay, it crashed. Why do you think it crashed? And yeah, it printed undefined, whereas before it printed my name or Miri's name. Like we ran the code and it's undefined. Yeah.
An empty file now?
It's an empty file now. Let's see if the file is actually empty. It's empty. Why do you think it's empty?
It didn't get an event to write, the trigger to write to the file.
Okay, let's see if that's the case. If it got any event to write to the file. So I will debug this code. Do you remember my words about the importance of debugging from the last week? Yeah, it's really important. It is the skill that will set you apart from your competitors, which is every other single software developer out there. No, don't be intimidated. But anyway, I ran my program by clicking this Start Debugging button, and it actually stopped at line 4 here over at the database function, which means it's actually getting a instruction from me to save it to the database. But let's see what people are. So, okay, I have 2 persons here, as you see here, and I'm trying to write them. What happens? Okay, I load them, and it crashes. Unexpected token U in JSON something. And there's no data saved. Why? There was a question before we ended the previous hour about, then how do we actually write our code? And another comment here that there has to be a callback function, right? Because now we're doing something asynchronously. Are there any callback functions here on the left in the database file? No, right? We didn't give it any callback. What should we do in this case is add a callback function as a parameter here to save, which is denoted as CB for callback, and pass it onto the writeFile function. This means, hey, I want to write something, okay, to the disk. I know that you will spin some hard disk and write bits to that piece of machine mechanically, and whenever you're done, just use this callback function that I'm passing to you as a callback function, okay? And it will do so, because unlike humans, machines really obey your commands every time. So what we have to do is we have to give the save function a callback function. It will get something like an error parameter, and let's log it. So I'm putting a breakpoint here, and another one here, and another one here. Now if you remember my first words about synchronous versus asynchronous programming, I told you that it was all about order of execution, okay? And that I didn't imagine that words. I got the inspiration from over there about the order of execution. So thank you for your collaboration. So tell me which lines will execute, or what is the order of execution here? We have line 12, 13, and 16. Which one will be the first one to be called, to be executed? When I run this index file, which is the first line after all these, obviously after all these lines, which is the first line that will get executed? 16? 12? 13? Anybody who says 13? Good, we don't have any fortune tellers. Because that never happens, right? There's no fortune telling. 13 could never execute because it's in the future. It will happen after we write something to the disk. Yeah, obviously all these are synchronous code and 12 will execute first. Let's see that. Yes? Or let's stop this and run it again. Line 10 executes and then line 12 executes. The question now is, which is the next line to execute, 13 or 16? Raise your hands if you say 16. Okay. Raise your hands if you say 13. One? No one else? Okay. Yeah. I mean, if this were synchronous code, and it were before, when we use write file sync, 13 would be the next one to execute. But when I run this, when I click continue the execution, 16 will happen first. Why? Because we just told the hard disk to spin to give me the file, but it didn't call us back yet. It's just working on the file. It's fetching the file for us. Probably now in the background it did. It prepared the file for me, and while I'm waiting here or executing this line, when I run it, okay, oh, sorry, fails there because like, well, don't go into the load anymore. I'll just go and comment out this section so it will not confuse us. And let's start over. So I run it, line 10 executes, line 12 executes because they're synchronous, line 16 executes. Oh, let's add another line here, shall we? Are we there yet? Anybody with children here? Raise your hands. 1, 2. Is this something you get while you're driving? I was that guy in the family car. You know, after an hour, if it's a 10-hour ride, I spent the next 9 hours saying, "Are we there yet? Are we there yet?" And I knew that it would take long, but you know, it's just fun to piss off your parents. So anyway, let's run this again. Hopefully this time it will work. Okay? So line 10, line 12, I run it, line 16, I run it again. Now we have line 13. Why? Because we just have the callback. Because it wrote the file, and now if you go to data.json, oh, sorry, didn't yet, because this is a very quirky behavior. Come on, what is the problem? Okay, run it again. Yes, it's here because I'm running it from a different location. That's why it's saving to a different place. But then let's clear this, go back to our index file, run it again. See, I'm on line 10, line 12, line 16. This file is empty. And line 13, this file is now full. Or let's put it on the side here. Let's clean it. Run it again, line 10, line 12, line 16. When I'm at line 13, the file is full. This is asynchronous because I'm hitting another device, another machine actually is doing this task for me. It's writing to the file system. It's not in my code. It doesn't happen in my code. And I told it in my database file, write the contents that I'm passing you, write the people object or array into data.json and call me back when you're done. Or execute this CV function, callback function when you're done. And this is the CV function. This is where I'm defining it. I say database save these instructors, and here's my callback function. Okay? What it does is it passes on that callback function to the right file. It's called continuation in programming and passing. So I'm just passing in a function down the line to be executed when an action is done or when an event is triggered. As you said, like the write event is triggered. That's what it does. And yeah, I run it, and oh, here it is. Hello world, are we there yet? And maybe we can write here, we are finally in the future. Let's run it again. You get hello world first, you get are we there yet? And then you get we are finally in the future. So the order of execution has changed. It's not line by line anymore. Okay? Because line 12, line 13, simple logic tells you that it should, like 13 should execute before 16, but it's not the case. Because it's asynchronous. We changed the order of execution. We told, hey, I don't want to wait until you write the file because I'm writing a huge file with big personalities, okay? It may be two simple objects with ages and names, but they are big people. So I don't want to wait for you. Just call me back when you're done. And I'm just going on with my life as if I don't care about the database. And whenever it's done, it just calls me back. Now, there is another magic function in JavaScript to just wait for nothing, and it's called set timeout. Now the exact details don't really matter, but it takes in as a first parameter and a function to execute, and as a second parameter a number in milliseconds for when it should execute it in the future. So just to simulate that this is a slow database or a slow hard disk, I make sure that the save function will run 5 seconds later after I execute it, okay? So I'm running my code. Again, line 10, line 12. Line 16, I'm hitting run again and just waiting. And after a certain period, like 5 seconds, you get, okay, we're finally in the future. Okay? And when I remove the breakpoints and run the code again, you'll see you'll get the 2 messages instantly, and we're still waiting. And then 5 seconds later, we get the final message, we are finally in the future. I could make this 10 seconds, okay, and run it, and it will just work. All right? After 10 seconds, it will say we're finally in the future. Now, Imagine you have a kid in the car and they are determined to bug you. They are determined to piss you off. Would they be satisfied with only a single "Are we there yet?" No, right? They would repeat the question over and over again until you're really pissed and you shout at them, or until you're actually in your destination. So let's simulate that. There's another identical or counter or similar function to set timeout, which is called setInterval. It also takes a function as the first argument and a number as the second argument. Let's give it 1000. What does this mean? This means that every second I will execute this console log here. Okay? Every second I'm executing this this function. Let's see how it works. I'm running the code. Hello world. Are we there yet? 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 We're finally in the future. And this is a dummy kid that nobody should have because it's still asking me if we're there yet. But yeah, this is basically how asynchronous programming works. I asked this function to execute. I asked this save to execute. And it said, okay, I will call you back when I'm done. And it started working. And after 10 seconds, it called me back. But I didn't just stop and wait until it finished its job, right? I just went on. And actually, I printed 10 messages until it told me that we are there. So this kept on executing. I didn't block the execution. And this is the first keyword that you will hear about Node.js. It's a non-blocking environment. It doesn't block the execution of your code just because you're waiting for something. Okay? And yeah, we continued the execution and we logged 10 more times. And after 10 seconds, we wrote to the database. Let's see it in action here. I'm deleting this file, okay? And I'm running the code again. I said, hello world, are we there yet? Are we there yet? Are we there yet? The file is still empty. And after 10 seconds, the file is full and we get the message, we are finally in the future. Does it make sense? Raise your hands if this is clear to you. Perfect. Yes, that is the number of hands that I want to see. If it's not, don't worry. We still have the video recording here. And we still have the Slack. And we can talk the whole week about this. Cool. Now let's move on to actually week 3. Now, if you clone the file that I wrote on Slack, it's fine. If you didn't, it's also fine. Don't worry about that. But what you get is basically a folder like this on the left, week 3. It has another folder inside called files. And in that, we have 3 more files. 1.txt, 2.txt, and 3.txt. There are 3 different files. You can create them on your own folders if you didn't clone my repository. It's under week 3. If you didn't clone it, don't worry. You can create them. And you can ask for help. I have some friends around. And yeah, I want to operate on these. Now, pardon my pathetic German, but these are kind of the extent of the German words that I know. First, second, and third. So this is the first file, this is the second file, and this is the third file. Now I want to read these files in order because first is first, second is second, and third is third, right? I want to read them in order, and I will try to show you how you can do that asynchronously, because that's the whole idea of Node.js. It's asynchronous. Let's start with an example. I already put an empty index.js file, so if you have it, that's fine. If you don't, that's also fine. Just create an empty file alongside this files folder and follow along. To read the file, we first required the file system module, right? We first said const fs require fs, and let's not forget the semicolon. And let's first do it synchronously. Const text1 is the name of my variable. Fs read file sync files and 1.txt. Let's go to v3 and execute this. And console log text1. Oh, I need to pass in the second parameter, utf8. Okay. So here it is. The contents of the first file are set. I run nodemon and I get it. Now, please follow along and do this with me. And if you need help, again, raise your hands. I have several friends walking around who are waiting for your hands. Don't be shy. They are here for you. And make good use of them here. And here it is. The file structure and raise your hands if you got this already. All right, good. Are you using nodemon? Yes, okay, fine. Okay. It's just 3 lines that I wrote. Oh. And this is the version that we did on week 2, right? We're reading it synchronously. That's why the order of execution is exactly the same as the number of lines. So line 1 executes first, line 3 executes second, and line 5 executes last. I can go and get the other ones. If you press tab here, like you can choose between these files and the names, the functions. If you press tab, it auto-completes for you. So files 2.text, utf8, and there's another shortcut to clone line. And I'm logging them all. And this is what you get. Erste, zweite, dritte. Is my pronunciation all right? Yeah, I really suck at German. But yeah, you see they are in order. And anytime you run this, they will execute in the same order. Because this is synchronous code, right? Make sense? Yeah. Now, raise your hands if you followed so far. Good. Now let's make them asynchronous. How do we make them asynchronous? What is the first step? Raise your hand and tell me. Anyone? How do we make this asynchronous? Yes, remove the sync, please. So here's another shortcut. I keep pressing Alt, and well, yeah, because this is a live demo. Yeah, and Shift. I can select all 3 lines and then delete them. Repeat what? Oh yeah, I press Alt and Shift on my keyboard, and it gives me multi-line cursor so that I can select multiple lines here and delete them, or replace them with whatever I want. It's like Bart Simpson's, Do you remember the message that he was writing on the blackboard? I will not commit any crimes. That he had to repeat it like 100 times, or like I will be a good person. I'm talking about Simpsons and the opening scene. Anyway, but yeah. Okay, I'm getting errors. That's fine. That's great. Actually, warnings. It says calling an asynchronous function without callback is deprecated, which means it won't be supported in the future. So like you're doing it wrong. Please don't do that. And when I'm logging it, let's say, are we there yet? When I'm logging it, you see we are getting undefined because this is asynchronous and we didn't get the file content set because we didn't give any callback functions. Now, since this is actually 3 files, let me speed this up because I don't want to type everything 3 times. I will use an array to do this, okay? If you remember my previous example, 1, 2, 3, and then I said, what? Map. Yes, see how it all fits together? Of course, this is not coincidence. But what I'm gonna do is, I started 1, 2, 3. I want to map these to file names because the file names are, 1.txt, 2.txt. There's a pattern there, right? I will say number. What did I do previously in the previous hour? What did I write here? Number times 2, right? To multiply it. Now I'm going to write a string, and I will say /file/ number.txt. Sorry, const file names. Let's comment these out for a second. I will do it with command /. I select the 4 lines and hit command / and it puts the slashes for me. And do a console log here, file names. Let's see what they were. So see, now I get an array of file names. Now this is tricky. See, this is not a normal quote. It's a special quote. It's called a backtick or accent sign. And you have to figure out where it is on your keyboard. If you have an international keyboard, it's the key to the top left corner. Sometimes, if you have a US keyboard or any other language, it is a key above the control key. And if you have another language, I don't know where it is. Yeah, the other one. So maybe. Yeah. The backtick. We're looking for the backtick. Anyway, if you don't have it, don't worry. The alternative is you can use normal quotes, and instead of this, you can do normal quotes, files, close quote, plus number, open quote, and .text. So it's the same thing. But I will use the first one. Who got the backtick? All right, cool. I'm gonna go with the backtick. But yeah, if you can't find the backtick, you can use the second syntax, which is a little bit more characters, a little bit longer, but yeah, it's fine. Anyway, so I get the array with the file names. Who is following me up until this point? Raise your hands. Cool. The others, raise your hands and call an instructor. They're playing with their phones, so just make them work. Utilize them, okay? All right, I have the file names. Now I want to read the contents of the file names. So actually, I can chain map commands. So map gives you an array, right? An array, the resulting array, also has a map function. So I can now get a file name in the new map function. This is like black magic. I can do read file sync. Okay. File name, comma, UTF-8. Now this became files. All right, I save it, and you get the result here. We now have the contents of 3 files in an array here. I will delete this line to keep you from confusion. And yeah, we first started out with numbers 1, 2, 3. We first mapped them, or secondly, we mapped them to strings of file names here. And then we mapped the result of file names to actual contents of the file. Does it make sense? Yes. And then we log the files. So this is very, very handy. This is something that you're going to use all the time when you're doing JavaScript. You will have an array of objects of people. You will map them to new people all the time, and you will map them to console log or whatever another function to get their properties or whatever you want to do with them. And yeah, this is called chaining. We chained 2 different map functions together. Is it soup? It smells like soup. Freshly cooked soup. I don't know. Anyway, okay. Now, how do we do these asynchronously? I told you that we need a callback function, right? You don't have to repeat this. I will type quickly, but just watch it. I'll do read file and give it the file name and UTF-8 and give the console log as the final parameter and save it, and you get null is the error, and the second one is the contents of the file, or you can do error contents and console log contents. So this is what gives you the contents of the first file. I duplicate it and use the other 2 files. Oh, what happened here? I got them in a wrong order. Erste, dritte, zweite. Erste, zweite, dritte. This time it worked in order. I save it again. Oh, this time the second file loaded faster. Zweite, erste, dritte. Every time I refresh the execution, every time I run this file, I get a different order. Do you notice that? 1, 3, 2, 1, 2, 3, 1, 2, 3, 3, 2, 1. Every time I run it, I get another order. Why is this the case? Raise your hand and make a guess. Yeah? Yeah, this is asynchronous. And unfortunately, physical objects and real-world objects like hard disks are also unpredictable and asynchronous. Sometimes they load fast, sometimes they load slowly. And I'm just running, I just told the file system that, hey, I want these 3 files. And apparently, in the last execution, the third file loaded the earliest, and the second file loaded secondly, and the first file was the slowest, so it loaded the last. So I didn't get the order that I wanted. How do you make it happen? The command was, you have to run it in the callback function. So actually, it's something like this. When do I know that the first file is read? Within the callback function, which is line 10, okay? Now, this is the line that will be called when we are sure we have the contents of the first file. So if we first want to display that one, this line 10 should run before line 12. How do we make sure line 10 always runs before line 12? In fact, if you run this right now, you'll notice that it will never actually run accordingly. Like, it will never run before line 10. So let me correct this and so that I can run it. So I put a breakpoint to line 12 and line 10. So anytime you run this, 12 will be first, and then 10 will follow. Because 10 is asynchronous and 12 is synchronous. So how do I make sure 12 runs after 10? Raise your hand and give me an answer. Come on, just give me a guess. How do I make sure 12 runs after 10? Yeah? Yeah, exactly. I select this line, I crop it or cut it, and move it inside, paste it inside the callback function. Now, this is synchronous. At least calling for the file is synchronous. So I made sure line 11 always runs after line 10. Okay? And yeah, you can test it. So, erste, dritte, zweite. Erste, dritte, zweite. So whenever you run it, you will see the second file will be loaded before the first file. So whenever you change it, the second one will never come before the first one because it runs after we read the first one. All right? So how do I make sure line 13 executes after I read the second file? Raise your hands and tell me. How do I make sure this runs after I read the second file? Yeah? Yeah, of course. I do the same thing. So I put some curly brackets here so that I can write more code. And I cut this line and paste it here, like this. Okay? What does this shape look like? Here. This shape here. Like, whoop, whoop, whoop. There are 3 sides. What do we call it? A triangle. Yeah. And when you add another dimension to it, it becomes a pyramid. Right? This is what it's called. It's a callback pyramid. It's a pyramid of functions inside functions inside functions. And this is the only way that you can make sure stuff runs in order. So this is the biggest problem in JavaScript. if you want to ensure the order of execution, you have to repeat this pattern all the time. Like, let's go back and say, hey, I want to reread the first file after the third one. What am I going to do? I'm just going to copy this line here and put it here. Something like this. Oh. Erste, zweite, dritte, final one. And whenever you run this again, you will basically get the same order of execution. So this goes on and on forever. When you need more operations to run in order, and when they are asynchronous, you have to repeat this. And as you can already see, it's not fun. It's not fun to count how inline they are or how many spaces it comes before them. So there has to be another way of doing this, right? This doesn't look good. This is actually has a very bad name, another nickname in programming. It's called Callback Hell. Because like JavaScript developers deal with this thing every day, 10 times, 20 times. Like everything they are doing is asynchronous. They are making a call to a server, they are waiting for users to do something. Everything is asynchronous in JavaScript. Which means when you want to do anything, you have to do it like this. And it gives you an infinite number of functions inside other functions, and it turns your life into hell. That's why it's called Callback Hell. All right. Obviously, this is not how we write code. Like, there are alternatives to fix this problem. And now I'm going to talk about those. So again, you didn't really need to follow me into this callback hell. I will never turn your lives into hell. So I didn't ask you to type these, but maybe I will put them online. But what I'm doing next, please follow and type it with me and try it out, okay? I will not delete this. I will just comment it out so that it stayed there. And there's a blank page here. I will introduce a new concept called a promise. In some languages, it's called a future. Any Java developers here or .NET developers? Raise your hands if you're familiar with a concept called a future. Maybe, there, yeah, kind of, yeah. A future is a special construct in the language, or a promise is a special construct in the language for asynchronous programming. It basically wraps the asynchronous nature of our operation in a nice way, so that we don't have to do that callback hell. It says, let me know in the future whenever you're done, and then I will do something else. So I'm giving you a command, read this file, and I will say, then I'm going to do this, okay? So if you remember my words about designing the software, I will write first how it should look like, and then explain how it will happen. So let's say I have a function called read file, all right? I want to have a function called read file that will hide away all the ugly complexity of reading a file. I will give it a file name. And let's say I will give it like file1, read file, file1. And if you remember, the original goal is to keep the order of execution. So I want to read the files in order. I want to read the first file, the second file, and then the third file, and then maybe finally write another message. So how should this look like? I said read file, file1, and then, okay, read file 2, and then again read file 3. So, or I can write it like this: read file, and then read file 2, and then read file 3. Yeah. What? What? Oh, did the screen disappear? Sorry. Are we still recording? We're still recording. Fine. And then, you know, print a final message. Obviously, when you run this, you'll get a lot of errors because none of these functions exist yet. There is no read file function. Okay, but this is what I want to do. This looks much better than this one, right? This was the previous version. And basically, this should be the same. This version should be doing the same thing. And it's a lot neater because I want to keep the order of execution. I told it to, you know, read this file and then read the second file and then read the third file and then print a final message. Raise your hands if you follow the logic that I'm trying to set up. Perfect. So let's implement this. If you remember, I told you about promises, and we will now create a promise. And I want to read the first file, and then I want to read the second file. So I want to actually have the read file function promise me that it will give me the contents of the first file, right? Because if I don't get the contents of the first file, I won't be able to read the second file. That is my condition that I set up here. I first read the first file, and then I go to the second file, all right? So I need a promise. I need a proof or a guarantee that the first file will be read. So I will ask the read file function to promise me that it will give me the results of the first file. All right? Does the vocabulary make sense? I ask it to promise me to give the contents of the first file. So how do we do that? Let's create a function called read file. Read file equals a function that takes in something called a file name, a parameter called a file name, and it will return a new promise. Okay? Now, promises are something that you can count on. If you get a promise, you can be sure that it will execute and do something, and then you can do something else. Obviously, real life is a little bit different. Sometimes we cannot fulfill our promises, right? Sometimes they fail. This is the case in programming as well. Sometimes promises fail. So we will have to be ready for that as well. We will have to catch when they fall or when they fail. That's another keyword. But for now, let's keep with this syntax. So basically what we do is promise is something that takes a callback function with two parameters. One is resolve and the other one is the reject. Okay? And then you can implement your logic, which was, you know, read file. And we're passing in the file name, UTF-8 as the second parameter. And if you remember, we need to provide a callback function to read file, right? It will give me an error or the contents. So there is a little bit of a triangle and callback hell here as well. But normally this is some code that is written in another file. So you don't really worry about this. You don't see this. You as a user or as a developer, as a consumer of the library are interested in this part. Whoever unlucky person is developing this part, the library developers, they can deal with the callback hell and you don't care. So that's kind of fine. So what we do here is we need a way to indicate that the promise is fulfilled, that it's over, that it's done, that we read the file, okay? And we do it by calling the resolve function. It's actually a function that you can call with any value here, and I'm passing in the contents. So let's not forget the semicolons. So again, read file is a function that takes a file name and returns a promise. It promises me that sometime in the future it will resolve my promise with some contents. Okay, and I told you that there might be errors sometimes, and you have to catch those errors or handle those errors. And the way we do it is, if there's any error, we say, well, return and reject this promise by giving out the error. Maybe you couldn't find the file, that's fine. Maybe somebody deleted the file, or maybe the file has a different name, so you reject it if an error happens. All right, let's define the file names here. If you go back, we first defined the file names, right? It's an array, and we mapped it to some file names. I didn't comment in the last file where we read the contents, so I just have the file names here. In fact, let's keep them down here so you can see them. So how do I get the first file name to pass it to the read file function? Raise your hand and tell me. Sorry? File 0, like this. This is the first file name, right? I'm storing the file names in an array, and I want to get the first one. So hopefully this thing will work. Let's test it. I said then, let's say console log, and save it. Whoa, it worked. See the magic of Node-RED? It executed as soon as I saved the file. But yeah, this is basically what happens. I said read file, okay, and then console log. Print it to the console. I could pass in any function here, like this, like contents, console log, the result is here, and contents. You don't have to write this, but yeah, you see it works. The result is here, state. So, but I just want to log the contents, so I say console.log. It's as simple as that. All right. So this works, right? Now I want to read the second file and do the same thing. I will just uncomment this. And of course, this is not file 2, it's files 1. And yeah, I got the message finished. How do I know it read the contents? Well, I don't know. But what I can do is I can again do a then console log here. Now, tell me the messages that I will have when I run this code, when I save this. What messages will you see on the screen? when I save this code? Raise your hand and tell me. I will help you out, don't worry. Just try your luck. Hello? Oh, what is there? Raise your hands and tell me. No, you're talking too much. I want someone else. Please raise your hands and we will do it together. All right, I have your back. You will not fall. Come on, I need a candidate. Or I will pick you. Pick one. So, who is the bravest? Are you? You're calling for help, all right? Okay. How about you? Oh, okay. That's good cheating, but then you can tell us. Yeah, zweite and finished. So it will print out zweite and finished. It didn't print out the first one. And let's explore why. Raise your hand and tell me why it didn't print the contents of the first file. And it's actually a very easy question. It's not a tricky question. Yeah, please. Yes. Oh, that's actually true. But there was another hand there. Yeah. Exactly. So if I move this console log from here to here, like I moved it one line above, I switched the lines. So what will happen? What message will I see now? First, and then, and finished. Yeah. Erste and finished. Of course. Now, I didn't do this because this will kind of fail. Oh, it didn't. Wow. All right, that's fine. So yeah, I can actually do that as well. This used to fail before. Maybe they fixed it in the previous versions because console log doesn't give you any promise. So there's no then, but yeah, no, actually this works and it worked all the time. So yeah, well, I get the first one, the second one, and the finished one. So let's have the third one as well, okay?
So could you explain one more time why that was?
Why this works?
Yeah.
Well, I mean, I read the file, okay, and read file gave back a promise to me. It said, in the future, I will resolve this promise. I will resolve myself with the contents of the file that you're asking. I read the file, and then I logged it. And actually, thens are chainable, so you can call multiple of them in sequence, as we did with the map before. So I said, okay, then let's read the second file, all right? And then I said, okay, then log it, the second file. And now what I'm going to do is I'm going to put the third file here, and then put another console log after that. And I get erste, zweite, dritte, and finished. I can go on forever. And you see there is no increase in the indentation. So it's not a triangle anymore. It's just a single line here that we see. Okay? So, yeah. So this is a lot easier to read, yes please, than the previous one. Sorry? Well, we could do that, and technically it works like that, but when you read it, you know, it doesn't have to happen in that, with that indentation. Because although this console log is executing after the read file, it's not inside the read file. You increase the indentation when you go inside another block, as we did here. If you look at this example here, we were inside the callback function of the first read file. Here on line 10, we are inside the callback function of the second one. Okay? And you see how there's a triangle here. This is called the Callback Hell. And you're passing around callback functions. And it's impossible to read when multiple callback functions are involved with if-else statements and other function calls. It's terrible to read. And this is basically equivalent to this one. Which one is better? This one's a lot better, right? So, yeah. Well, this is how we kind of tame the asynchronous nature of JavaScript and capture it and make it look like it executes in order. You know for sure that line 33 will execute before line 34 all the time, and line 35 will execute after line 34. So anytime you run this, sorry, let me comment this out. Anytime you run this, you'll get the same order. So this reads a lot better. Now there's another way with the latest version of JavaScript. You may be wondering why I was insisting that you install the latest version of JavaScript. Sorry, the latest version of Node.js, which comes with a new feature in JavaScript to make this look even better. And now I'm going to talk about that in the last couple of minutes. So I will go back to the read file function. We know that this is an asynchronous function, right? This is doing asynchronous work. It's reading a file asynchronously, right? Are you following me? All right, bear with me through this for a couple of more minutes and then we'll be free. We know that this is an asynchronous function, okay? We don't need to write all these thens. There's actually another easier way. And it starts by denoting this function as an asynchronous function. I just type the keyword async before the function declaration in the read file. I say, hey, this is an asynchronous function, all right? Please. Well, it's any function that executes asynchronous code and returns a promise. So if you have promises, if you return promises as we did, you can call it an async function and write this keyword here. It only works if you have a promise. All right? And by using this, I will try to simplify this syntax here. Actually, let's first design how it should look like. Because that's how you design software, right? So what I want to do is, since these are actions that repeat one after another, which means I'm actually waiting for the reading the file action, right? I'm actually waiting for it. I wait for the first file to load and then I'm logging it. I'm waiting for the second file to load and then I'm logging it. I'm waiting for the third file to load and then I'm logging it. I'm actually waiting a lot about these things. So I will turn it into another keyword. I'll say await. Okay? Read file, files 0. Now this should equal to a new variable called contents1 equals, oh, sorry, there is no space here. Contents1 equals await read file. And then I will write console log contents1, and this should work. Okay? And I will do contents2 await read files 1. And I will do console log contents2. Okay? And I will repeat this for the third one. 3 log finished. Now this should work. If you're coming from another language, this is already how you write your code. You don't have the await keyword probably, but you have a way to read a file. And this looks really synchronous, right? It's exactly the type of synchronous stuff that we did before. We had this one, if you remember, we mapped them and logged them. Or we had 3 different read file lines. And turns out that this is really easy to read. There are no indentations, no repetition of then and other forms, other keywords. This looks a lot nicer. But again, we're in JavaScript, and this should run asynchronously. That's why we have the await keyword. And well, when you save it, it won't run because there is currently a limitation. You cannot run async await functions in the topmost block. So you have to wrap them in a special function, which is a very awkward syntax. But I will basically create a new function here called main. And raise your hands if you know something called the main function. Yes, if you have any other programming experience, you probably know what a main function is. It's something that runs when you start the job, right? And I will put all my code in that main function and execute that main function. Now, is the main function synchronous or asynchronous? Tell me. Raise your hands and tell me if the main function is synchronous or asynchronous. Yeah? Synchronous. Raise your hands if you think it's asynchronous. Okay, 4 or 5. Raise your hands if you think it's synchronous. Okay. Well, it's not synchronous, of course. We're in JavaScript. And the underlying operation is asynchronous. It's read file here. Don't forget, we're still having callbacks here. We didn't remove the pain. We just offloaded it to someone else. Someone else is bearing the pain of the callback hell. And we're just writing this nice function, this nice main function here. But in the end, it's still asynchronous. So what I should do is I should put the async keyword here, okay? And run it. When you save it, you see you still get 1, 2, 3, and finished. And the order doesn't change. You keep the order. And that's basically how we write asynchronous code in JavaScript without introducing callback hell, without introducing thens and other stuff, by just putting these 2 keywords here, async and await. And yeah, this is basically the end of my presentation today. Thanks for coming. Okay, no, but yeah, this is the most advanced construct in JavaScript nowadays, and this is all the rage about JavaScript, async and await, because it removes a lot of pain from a lot of developers. Yes, there are some unfortunate people who have to deal with this thing all the time, but most of the time it's in libraries, it's hidden in libraries, and when you're dealing with databases and files, you are always writing code like this. So you get the whole benefit of JavaScript, all the benefit of JavaScript that's asynchronous nature and non-blocking nature, but it looks and reads really nicely. Like contents1 is awaiting or waiting for read file. Contents2 is waiting for read file. And the order of execution is now again exactly the same as the line numbers. All right. So again, thanks for coming today. And what about the homework? What? The feedback. Yeah, we have a feedback wall there. Please write down anything, your feedback about this session for the coming weeks, if you like this session or not. We promise we won't find you. But yeah, we collect those feedback, and they are what define how we work next. But yeah, please fill those papers before we leave. And the homework is
Slack? You give it in Slack or like you have to write that down?
what?
Homework?
Yeah, I will put it on Slack again, but make sure that your databases load asynchronously using these two keywords, async and await. And this time there's another challenge. Make sure you have different databases for each class you have, okay? For person, have another database. For, I don't know, class, or we had, hairdresser, or a book, or media, have different databases for each class and make use of async and await. I will write this down on Slack, and I will send a message to all the meetup participants for the Slack invitation. So if you're not on Slack, don't worry, we will invite you. And yeah, that's basically how it works. And thank you. Don't forget the feedbacks, and see you next week. That's very important. We obviously clean the tables and put everything in the kitchen back there, so that the next morning when nice people come here who share their home with us, find clean tables, and yeah, and they don't hate us.